we're now going to look at what George Ohm did to compare the voltage being used to push the charges through the wire. So there's a voltage pressure here, right? High voltage here, low voltage here, pushing that conventional charge through the wire. And Ohm, through his experiments, determined the relationship between that voltage value and the current value in the wire. Now, we are going to use a length of wire designated by a script L. And we're using a script L because later in the course in magnetism, capital L is used as a parameter for induction, and we'll talk more about that when we do magnetism. But we have a relationship between voltage and electric field that we're going to remind ourselves of first, right? So it's the electric field that is pushing the charge fundamentally, right, through the wire. And the relationship between the voltage, the battery, and that electric field is negative integral E dot ds. And we get a cosine of 0 degrees here, right? Because the charge is going forward, the electric field is going forward, so we have cosine of 0 degrees here. So this negative actually stays with us. And I'll talk more about that negative in a moment. And then what we're left with, right, is that delta V is going to equal negative EL, and that negative we think of as the voltage drop, right? We're going from a high voltage to a low voltage, and as we said, our script L is our length of wire. So the ds, when we integrate, becomes the length of wire L. Now here's Ohm's experiment. What Ohm did was he found that as the voltage increased, the current increased as we might expect, but he determined specifically that it is a direct proportionality, a one-to-one relationship. So we've seen this before with Faraday and capacitance, so we're going to play that same kind of logic game that we've looked at before, that the experiment showed there was a relationship, a proportionality between delta V and I. Since it's a direct proportionality, the proportionality constant has to be introduced, and that proportionality constant is the resistance value that we refer to when we talk about the resistance in a wire. It's the proportionality constant between the voltage drop and the current in the wire. Now, that equation has become known as Ohm's law in honor of Ohm. And it is always given as V equals IR. Now, there are a couple of things we always need to keep in mind. The V in Ohm's law, V equals IR, is always actually a delta V. So it'll be a voltage value, for example, 5 volts, but that's the voltage drop across what we will refer to as the resistor or resistance section of the wire. So the voltage drop across that section of wire that has a resistance R. The other thing that is never specified is the negative, right? So the negative is always left out. We have to know that it's a voltage drop. So we have to know that it's a delta V. We have to know that it's a voltage drop. And we will get much more comfortable with this, and it's not really a problem as we go along, but up front, understanding it for the first time, we need to make sure that that absolutely is known. So again, I will let you pause the video, get your annotations down, and we will move on.